section of our event today, and this one's even closer to home because this is part of what we call the North Coast Soil Hub. This is a North Coast Soil Hub production, I would say, which, to remind folks or those who aren't on, there are several people involved with that, or several organizations, but it is led by the RCD, and it's the Napa RCD, the Mendocino RCD, the Sonoma RCD, and Goldridge RCD. So those three counties are all involved, but we will be expanding, and I know Lake and Marin are coming on, and we will have a new coordinator soon, and so we look forward to continuing efforts like this. There's a lot more though just than these events, and so we're going to spend the next section talking about what the North Coast Soil Hub is up to. And we're very fortunate to have Miguel Garcia from the Napa RCD, who has been doing a great job leading the project and leading the folks from different RCDs, and also coordinating. We NRCS and other organizations have been participating too. So he's been coordinating that, and he's going to talk to us about it. He is the Sustainable Ag Program person over at Napa RCD, and he has a very similar job to myself as the soil and water specialist. And we're also going to hear from Shannon Capilasi from the Soil Health Institute, and she is helping us with the project, and we'll tell you about what she's up to. But it's great to hear from her because it was about 5 years ago when I first contacted her about working with the Oregon State University lab where she used to work, and this discussion began, and then she's taking it much further, and now she's with the Soil Health Institute, and it's going to be great to hear from her. So with that, Miguel, the floor is yours.
Thank you so much, Keith. Can you guys see my presentation just fine?
Yes, you're all good.
Okay, perfect. Thank you so much. Today, I will talk to you guys about what the North Coast Soil Health Hub has been up to with regards to our soil health assessments and field trial monitoring in vineyards. And I'll give you a little bit of background about the hub. The North Coast Soil Health Hub is a collaboration between the RCDs in Sonoma, Mendocino, and Napa counties, and more recently, we're working on incorporating also Marin and Lake counties. For the past 3-4 years, we have been focusing primarily on vineyard systems, but by bringing Lake and Marin counties, we're trying to expand on the kind of work that we're doing so that we're looking at soils in other agricultural systems other than vineyards. And this is an effort that we've been doing with the Natural Resource Conservation Service, NRCS, which is a branch of the USDA. And also we have been collaborating with the Soil Health Lab at Oregon State University. Today, there's a greater recognition that soil health plays a key role in minimizing the impacts to water quality and increasing drought resiliency and other impacts on climate changes, like we heard from our previous speakers. So the North Coast Soil Health Hub was created as means to raise awareness about these issues among local farmers and to communicate with them about the benefits of soil health or crop production, and also as a strategy to address the region's resource concerns. The hub serves as an active learning network for farmers and agricultural professionals who share information about soil health practices. We have our website, soilhub.org, where we try to communicate about all of these efforts. And this serves as our communication platform where information about ongoing field trials and regional specific soil health information is shared. The hub is intended at some point to be part of a statewide farm demonstration network, which is currently under development by the state, federal, university, other resource conservation districts, farm bureaus. So eventually we would like this whole hub to be part of this, be linked to this network so that the information that we have can be shared and can be discussed with other farmers who have similar cropping systems throughout the state. So the North Coast is well known about the viticulture work, but there's other regions in California and other parts of the country that could benefit from the work that we do. So we encourage you to go to our website, soilhub.org, to learn more about the work that we're doing. And if you have any questions, you can reach out to us there as well. This is the centralized location, so if you're looking for contacts on any specific RCD, this is the place that you can find us all. So as I mentioned, the main goal of the hub, or one of the main goals of the hub, is to increase the adoption of agricultural management practices that help maintain and improve soil health. So to do this, we have focused on two main areas. One of them is education, and the other one is research. The hub has made many efforts to facilitate the transfer of information regarding soil health to North Coast farmers. And one way is by hosting educational workshops such as this one. Like Keith mentioned, this is fourth year annual Soil Health Symposium for Sonoma County. All the other RCDs, we have also been putting some soil health related workshops throughout the years. This is the first year that we do it together as a hub, because we recognize that we are pretty much trying to communicate the same message. So we hope this is one of many years to come where the Soil Hub comes together to do these kind of workshops. In the future, we hope that we can do them in person so that we can do a little bit of hands-on learning and show you guys some of the work that we've been doing out in the field. The other way is by disseminating information related to soil health through our website and e-newsletters. So I encourage you to sign up to our e-newsletter if you haven't done so already, because that is the best way that you can learn about our ongoing research and upcoming events. In regards to the soil health research, we have been doing two primary things. One of them is the establishment of experimental trials to assess the long-term soil health and economic benefits of implementing various sustainable farming practices. And I will talk about in detail about this in a minute. The other efforts that we've been doing is conducting soil health assessments in various vineyards across the three counties, Mendocino, Napa, and Sonoma. And we have been doing this to determine how different soil management practices impact soil health. So I will go over a little bit of the efforts that we're doing, and the next speaker, Shone after me, would give a little bit more information on how we're utilizing this data. So looking at our experimental trial sites, these were established in order to assess the long-term soil health and economic benefits of implementing very sustainable farming practices. And this is important because we want to do this in a region in order to be able to figure out what works and what doesn't work in our specific region. We want to make sure that the concepts that we're trying to communicate about soil health are implemented in a way that would, as accurately as possible, represent what's going on in a region, so that we can represent as accurately as we can our different microclimates, soil types, and topography. We have collected soil samples at the beginning of all these trials. Some of them have been going on for 3 years. Some of them have been going on for a little longer than that. Some of them for a little less than that. But we collect soil samples at the beginning to create a benchmark. And we have either already collected soil samples this year, or we will be doing it soon to compare from the benchmark. And this will allow us to see what it's improving in the soil, what's working, what's not working. We intend to continue these experimental trials for a few years and continue tracking the progress. We should have more information to share with you about these trial sites and the data that we're collecting in the incoming months. So most likely you'll hear a lot more details about the actual data for these trial sites on our next Soil Health Symposium next year. So stay tuned for that. And we hope that we will be able to do it in person at that point, so that maybe we can have field days in some of our trial sites so that you can see firsthand what is going on there. In the meantime, if you're curious about more details about these specific trials, you can check them out in our website, the Soil Hub website. So the first trial site that I will discuss is the Huichica Creek Demonstration Vineyard, which is in Napa County and is owned and operated by the Napa County Resource Conservation District. This is located in the Carneros AVA. We have a carbon farm plan in place at Huichica Creek, which is assessing the long-term benefits of compost, biochar, till versus no till, and sheep grazing. In this vineyard, we have vine rows that have not been tilled since the late 90s, and they're right next to rows that are tilled every year. So this serves as an excellent side-to-side comparison of the long-term impacts of intense tilling. And it's important to do it side to side so that there's no soil or topography or microclimate differences. We're also testing how compost and biochar benefit soil health. And in here we have plots that have either received compost or biochar or both, so that we can assess the cumulative effect of biochar and compost, and then we can see what they do on their own. We also partnered up with Dr. Amelie Gadin from UC Davis to assess how sheep grazing benefits soil health. We have been grazing sheep in our vineyard, one block of our vineyard, for 3 years now. And a graduate student from UC Davis working with Dr. Amelie Gadin is assessing changes in soil health by having the sheep there. And they're also doing some assessments on how the grazing is displacing weeds. So very interesting stuff. We expect to have results to share about all of this by next year. The next trial site taking place in Napa is Gambo Ranch, which is located within the Oakville AVA in the middle of Napa Valley. And the vineyard is, the property is 130 acres in size, and about 525 are planted to vineyards. Here we are trying to understand how different compost application methods can affect nutrient and soil organic matter accumulation. And here we're looking at just what happens when you just do an overall application of compost without incorporation. And then we'll compare that with once you do an incorporation, what kind of differences we see there. We're also assessing how different tilling techniques impact soil health. So one of the things that we are assessing is the minority plow, and forgive me if I'm not pronouncing it correctly. So we're trying to see how this plow technique may affect soil health. In Sonoma County, we're doing a trial site at Shone Farm, which is owned and operated by Santa Rosa Community College. In here, we are testing the establishment of different cover crop species. Some of them are Blando Brome, Crimson Clover, Rose Clover, Sorrel Fescue. This vineyard also has a carbon farm plan that includes compost applications and reduced tillage. So these are long-term plans that will, in a way, change a little bit of the management. And this allows us to track over time carbon sequestration related to different management practices. Also in Sonoma, we have a trial going on at one of Jackson family vineyards. And in here, we are comparing how the frequency of tilling influences soil health to wine productivity and soil carbon sequestration. So we, in the previous trials, as we're looking at till versus no till, and then we're looking at different types of tilling with the minority plow. In this trial side, we're looking at the frequency. So how often you do it, how does that affect the incorporation of carbon into the soil and other soil health indicators and vine productivity, and how this affects also the compost benefits over time. In Mendocino, we have Ferrington Vineyard. And in here, we are testing the effects of several common cover crops and tillage management on soil health and vineyard growth. We have a couple different experimental trials. One is a no-till with a receding annual cover crop. The other one is a till with a biomass and a green manure cover crop. And then an alternate rows till system with the first two cover crop regimes, and also a no-till with a naturalized vegetation. More recently, this year, we're working on establishing a new trial site in Sonoma County, Thale's Vineyard. And these will be to investigate the impact and usefulness of applying mulch under the vine. Mulch will be banned one time, 2.5 to 3 feet wide strip under the vines on 1 acre block of Pinot Noir. The mulch will be layered roughly 6 inches. Probably half of the block will be treated with mulch and the other half with none. The entire block will be managed the same in all other regards. And just like at the other trial sites, we have collected soil samples recently in the tractor rows and under the vine in treated and untreated areas to establish baseline soil conditions. So this will help us track down any benefits to soil health, soil carbon sequestration. I also think that applying the wood mulch under the vine could help us understand its potential to mitigate weeds. So among all of these trial sites that we have been doing over the years, we're trying to investigate a lot of different sustainable management practices that have been popular or have gained some attention over the years among the North Coast vineyard industry. And we hope that this would allow us to track down much better what will work for a region, what wouldn't work for a region, and try to modify some of the things that we do to make it fit a little bit better into what we are doing in a region. And this is important, like I mentioned, because of soil variations, topography, and microclimate changes. So we are very interested to see how things progress over time. Like I said, a lot of these trial sites have been going on for a few years, and we have already made an effort to collect soil samples. So we will be able to share a lot more information with you in the incoming years. The next effort that the Soil Hub has been making over the past few years in relation to soil health research is soil health assessment. So we have been conducting soil health assessments in vineyards across Napa, Mendocino, and Sonoma counties. And these soil health assessments involve the collection of soil samples as well as some in-field testing. And I will discuss in a little bit more detail in a second what these soil health assessments involve. And the purpose of these soil health assessments is to determine how different soil management practices impact soil health. We are particularly interested in different management approaches for both the undervine and the middles in between vine rows. So for the undervine, we're looking at herbicides, use of herbicides, cultivation, and mowing for controlling weeds and vegetation on the vine. And for in between the vine rows, we're looking at till, no-till, alternate till, and the use of various cover crops among these systems. So far, we have assessed soil health in 75 vineyards across the 3 counties and collected close to 300 soil samples. And we expect to collect an additional 130 samples this year. We have tried to represent different soil types, microclimates, topography, and different soil management practices across the 3 counties to accurately, or as accurately as possible, represent a region. And the process of conducting a soil health assessment also has an important educational component, as it fosters a farm discussion and interest in soil management, because the participating farmer is given a one-on-one technical assistance and an opportunity to discuss their own objectives, interests, and potential barriers to adopt in soil health practices. So it's a great way to begin the conversation with growers about looking into improving and maintaining proper soil health. The farmers are introduced to the concept of soil health indicators and implications for meeting their own objectives. And this helps farmers move beyond traditional soil tests to a greater understanding of multiple soil functions and introduces them to emerging technologies of an integrated approach. We look at soil health in the same way, in a similar way that the USDA, Natural Resource Conservation Service, looks at it. They define it as soil health as the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. So a healthy soil is a soil that is able to do its function, and in the agricultural system is to be able to maintain proper crop development. The soil health concept recognizes that the soil is a living system. So this is what we're looking at. We're looking at a living system, and as such, we look at physical, chemical, and biological properties. And we look at these different parameters in order to determine how the soil is functioning. And the idea is that we will create some sort of scoring scheme, and I'll talk about it in a second, that would allow us to give growers a score of how their soil is performing or how their soil health is in relation to the rest of the region or to what we will consider a healthy soil. And we are doing this by sending samples that we collect to Oregon State University for a comprehensive soil health analysis, where they test the different physical, biological, and chemical soil properties. So this is how we're defining soil health. It's the ability of the soil to do its function in relation to all of these different physical, biological, and chemical parameters. So what we're looking into is texture, which influences water infiltration, the potential to store organic matter and nutrients, the aggregate stability, which influences water infiltration and oxygen moving to the soil, changes relatively rapidly with soil management changes because of the role of living organisms in the soil aggregation, such as fungal hyphae, earthworms, bacteria, etc. So it's important to keep an eye on it. Available water holding capacity, which is the amount of plant available water in a given soil profile. The biggest influence on available water holding capacity is the soil texture, with loam and clay loam soils having the greater available water holding capacity. It's also important to track down increasing soil organic matter, which as soil organic matter increases, available water holding capacity will also increase. pH influences nutrient availability, soil biology, and plant health. Electric conductivity, which is a measure of soil salinity, which it's not a big, it's not an issue as much for us here as it is in Southern California, but it's important to keep track of that. We also look at nutrients, NPK, calcium, potassium, magnesium, the whole shebang. Cation exchange capacity, which is important to determine the storage of nutrients, such as potassium, calcium, magnesium, positively charged nutrients. The total organic carbon present in organic matter, which is a sort of nutrients and improves soil structure and water holding capacity. And this is important because storing greater amounts of carbon in soil, i.e. carbon sequestration, it's an important mechanism for reducing atmospheric carbon dioxide levels and mitigating climate change. And organic matter is a source of food for microbes. Soil respiration, it's an indicator of soil microbial activity. Potential mineralized nitrogen is amount of organic nitrogen converted to plant available mineral forms under controlled conditions. Bulk density, which increases with soil compaction. Increasing bulk density, it's a negative indicator for healthy root growth and water and air movement in the soil. Water infiltration is measured to estimate the soil's ability to capture rainfall and prevent surface runoff and erosion during high intensity events. And compaction, which can restrict root growth and slow down water movement to the soil profile. So this is how we are defining soil health. It's a list of the different parameters that we are investigating. And the objective is, for this research, is to develop a regionally specific tool to aid in the interpretation of soil health assessment data. Currently, there's no regionally adjusted data-derived tools or thresholds or scoring systems available in California to guide management decisions related to soil health. So when a farmer sends a soil sample for analysis, they may get some recommendations from the lab, but those are more or less generic. They are not tailored or they are not calibrated to our soils, our microclimates, our topography. So what we want to do is we want to utilize all of our data to develop a tool that will allow all of North Coast farmers to be able to get more precise soil data interpretations and the results that are tailored to their soil type, microclimate, and topography. So similar to what I have here in this scoring system right here, this is very similar to what Cornell University has been doing for the region. So anybody that is farming in the close to Cornell University in that region, they can look at this scoring system and see if there are different parameters that I described in the previous slide. How do they score according to that? So are they in the green, the yellow, the red? Do they need to take action? Do they just need to keep an eye on it? Do they need to not do anything? So we want to develop a similar tool to this that would allow our local farmers to be able to understand more precisely how their soil health data it's compared to the rest of the region, but also compared to particular standards. So this should allow North Coast farmers to have the necessary tools to help them improve and maintain adequate soil health. So we want to develop these tools to be able to help them make better, more informed decisions. And the way that we're planning to develop this scoring tool is by compiling all of our data we have so far from the 300 plus soil samples we have collected so far into a database that will allow us to identify regional specific patterns between the different management practices and soil health. We will then develop the scoring system similar to what we have here, and this will allow the farmers to interpret soil health analysis results and be able to make necessary adjustments. The tool will be yes.
Yeah, we got a little under 15 minutes till question and answer time.
Okay, I'm wrapping it up in the next 30 seconds.
Great, thank you.
Yeah, let's see. So once we compile all of our data into database, then we'll be able to develop this scoring system. And our objective is to have the database and this tool developed by the end of next year. And in the meantime, we have begun analyzing the data we have so far to look for any patterns and to fine tune the parameters we are analyzing. Our next speaker, Shone will discuss in a little bit more detail because she's helping us out with this database development. So she'll be able to talk a little bit in more detail where we are with this and where we are heading and how our efforts compare to what the Soil Health Institute is conducting. So with that, I thank you for your attention. I think there will be time to ask me questions after our next speaker. So please check our website and let us know if there's anything we can assist with you. We're always happy to hear from you. Thank you.
Okay, I'm just going to jump in and say that our next speaker is Shannon Capellesi. Sorry about the pronunciation there, but she is the lead scientist and research soil scientist at the Soil Health Institute and is familiar with our program because she started with us when in her former job, and the title of her well, here it is. Her title is Soil's Capacity to Function. It All Depends. Take it away, Shannon. Thank you.
All right, thanks, Keith. And thanks, Miguel, for giving that great overview. Yeah, one of the things that we have been thinking is that the old scoring systems that have been working for soil health, they really didn't take into account these different issues that we have in the West. And so, yeah, Keith touched on this, so I won't get too far into it, but one of the things that we really think about with soil health is that it really is about the continued capacity of the soil to function. And so as we're doing all of our work, we really key in on that ability to function, recognizing that it is a vital living ecosystem that sustains plants, animals, and humans. And so this is a major part of our approach, that thinking about that soil's ability to function. Another thing that we've really been thinking about is that, for a long time, soil health has been largely focused on producers, which is great. That's on the ground, what we need as far as actually having adoption. But there's a lot of other people throughout the supply chain who are also interested in soil health assessments. And so we're keeping in mind that, farm advisors and supply chain people and economists, they all also want to be able to use a soil health assessment. And the thing that I think unites all of these different people is that they all want a clear interpretation, and that can be related to both economic and environmental outcomes. And so what we're trying to do is think about how we can make these assessments relative to the specific place and applicable, and comparable between locations, and then be related to those economic and environmental outcomes. So we've really been thinking about how each of these stakeholders will use the assessments. And so I think one of the things is, people want to know, is the management moving towards a healthier soil? And so one of the approaches I'll talk about here is that we're seeing soil health assessments for a long time are relative, right? You measure the indicators for a system that might be business as usual, what has been happening for a long time, maybe a more advanced soil health management system, and then also some kind of ecological reference or target. And so I'll talk a little bit about why we're using these minimally managed grassland areas as this ecological target for these regulatory and supporting services that the soil can provide. When we talk about the soil's ability to function, people ask, okay, well, is this soil actually performing each of the jobs to the best of its ability? And so we're doing this by trying to assess these individual functions that the soil perform. So we know that the soil both stores and cycles carbon. We need to put that carbon back into the soil so that the microbes have the ability to use that carbon and continue to cycle it, to use it, and to perform everything else. One of the other functions that is very relevant to production agriculture is cycling nutrients, taking that organic matter, turning it into plant available, or the nutrients that are on the soil minerals themselves, turning that into plant available nutrients. Another thing that I think, is well depicted here in this fence line picture is this ability to store and deliver water. So here you see, the same soil, the same climate. There's clearly a difference in the amount of water that can infiltrate into that soil. And it looks like that main difference might be the residue cover, right? So having other functions that we will be working on, not necessarily in the projects we've done so far, but suppressing disease and pests, as well as being this reservoir of biodiversity. And so one of these things that we have been going towards is an approach to a simple suite of indicators. Miguel showed that entire list that gives a very comprehensive view of it, but we had this project called the North American Project to Evaluate Soil Health Measurements. And one of the goals was to be able to create a list of minimum soil health measurements that will be able to say something about the soil's ability to function without being so cost prohibitive that people can't use it as a regular soil test, that somebody along the supply chain can't use it for a purchasing decision. And so we are looking for how these different indicators can be used in conjunction to approximate specific functions, and how that can then allow us to better assess the direct and indirect impacts of management practices, the land degradation or regeneration. And by looking at these specific functions, we think that that's going to be able to allow us to better relate the benefits of improving soil health to the economic and environmental outcomes. So in this giant project, one of the things that we really wanted to do was understand how these inherent place-based drivers are influencing the soil's capacity. Like Miguel said, that there are a lot of soil health assessments have only assessed a small amount of inherent features, and we realize that there are many things that create a unique soil, right? So there are just these layers of interactions, the plants and the soil organisms and the climate and the parent material that make these soils unique. And I think we're all becoming more aware of just how pivotal the microbial community is in the soil functions. And so what you see here is a map with a climate moisture deficit, where the dark blue colors indicate that there's plenty of water, more water than is needed for crop productivity. And the warmer the color, the more severe that water deficit is. And each of these black dots are the 124 long-term agricultural research stations that we sampled in this large North American project, where we were really trying to evaluate these indicators. We had the privilege of actually using microbial, of doing full genomic sequencing, 16S and ITS sequencing. What you're seeing here is called a detrended correspondence analysis. Don't worry too much about exactly what it means. This is the bacterial and archaeal communities. And each one of these dots represents a single soil sample from a replicated long-term research trial. The dots are colored based on this Hargreaves climate moisture deficit. And in order to understand this, what you need to know is that the closer two dots are to each other, the more similar that overall community is, right? And so one of the things that we can take from this is that the overall community that is in that place is really driven by the climate, right? So we see these soils over here where we're in this hot, dry climate, low, high evapotranspiration rates, and the microbial community that is there, that is performing all of these functions, is very similar. Where we have these really wet soils, we again see these gradients, and obviously there's differences, right? There's going to be differences in the community based on management practices, but this is really an inherent driver of the microbial community. Another thing that you'll see throughout microbial literature is that the pH also drives the community. So here we have the exact same detrended correspondence analysis, where each one of these dots represents a soil sample, and the closer two dots are to each other, the more similar the community is. And you'll see a really clear gradient here going along the x-axis, where we have the low pH soils on this side and the high pH soils on this side. And this x-axis is describing 45% of the variability of the microbial community. So this is one of the tools that we are using to understand what inherent properties really need to be taken into account as we're trying to make the system. Another thing that I think is widely known by anybody who's ever worked with soils is that texture also has an influence on the soil's ability to perform these functions, right? So here we have a density distribution. We have about 2,000 samples overall in this database. And so looking at potentially mineralizable nitrogen and breaking it out into groups, the coarse, the medium, or fine, there is a statistically different potential to mineralize nitrogen between these textural groups. And so we think that this is an important characteristic that we take into account as we are determining how we are going to be able to interpret different soil health assessments in the context of the place where these soils really are. Again, with intact available water holding capacity, we see a significant difference between the coarse, medium, and fine textured soils in the amount of water that they can hold. And so, these are two of the functions that were most directly measured in our trial. And so we're using texture as part of that interpretation.
Shannon?
Yeah.
You got 5 more minutes and then question and answer.
All right. I got a little bit of a late start here. So I'm going to skip this just a little bit here. This is one of the things that we did was we said, okay, what indicators do we really need in order to understand our ability to mineralize nitrogen? The final answer, cut to the chase, was that we needed soil organic carbon, nitrogen, and respiration, along with these site-specific parameters, the climate, the texture, and the pH, to understand how that mineralizable nitrogen changes in the system, instead of measuring necessarily mineralizable nitrogen, because that's an expensive, time-consuming measurement. So maybe we can just use a simpler suite. Using that same simpler suite, we've also reanalyzed these pedotransfer functions, where we use clay and sand and organic matter to estimate how much water the soil can store. This red line was the old pedotransfer function, where folks they use the same parameters, but they were using repacked cores instead of using intact soil cores. And we see that when we use intact soil cores, we have this big difference by soil organic carbon, where something with more soil organic carbon holds more water. And so we have redone these pedotransfer functions, taking into account the soil organic carbon by matching that to what's going on in an intact core. And here, then, instead of having no difference by carbon, we have a big difference, which is much more reflective of what producers actually see. So we're using kind of this simple suite of indicators. Soil organic carbon talks to the direct impact of the soil's ability to store carbon. Carbon cycling, we are looking at using carbon mineralization or a CO2 respiration with a 24-hour incubation to measure that carbon cycling impact. Aggregate stability is well related to erosion resistance. And so we have kind of this minimum suite that we're coming to, where we take into account that texture and pH and climate, and then have this minimum suite of measurements that helps us with these direct functions, as well as being able to talk about water storage, where we use those to assess water storage. We use those to assess nitrogen cycling. We also measured water movement, the saturated hydraulic conductivity as it moves through the profile. We don't have a good relationship to that one yet, but we're working on it. So to speak to this idea of the soil health target, I'm not going to get too much into the details here. This is a site in Oregon. On the left, you see what the soil looks like, business as usual after a hard rain. On the right, you see this reference perennial, where you've got this perennial grassland, these beautiful aggregates, tons of roots. Same day, right after a hard rain, and there's no ponding. It's easy to walk on the surface, and there's plenty of water movement. So we have that business as usual in the wheat fallow with more moldboard tillage reference site. And then we also measured a soil health management system. And here we had this wheat pea rotation instead of just wheat fallow, and we had no tillage. And this flow, this is that saturated hydraulic conductivity. So in this business as usual, we only had 1.5 centimeters of water able to enter per hour. In the reference, we had 32. And in the soil health management system, we're getting there, right? We're making progress towards that ecological maximum for that water moving into the system. It was at 12 centimeters per hour. So we can extend this also to some of the other functions that we want to look at. So we've got this capacity to store carbon, and we've got this sliding scale where the business as usual is at 0.8, soil health management system was at 1.7, and that reference was at 2.2. Similarly to the capacity to mineralize nitrogen and the capacity to resist erosion measured with aggregate stability. And so one of the things we're thinking about here is that soil health management system, if we have those end caps, we have a business as usual and we have a reference, we know how far along that chain we've made it. So they've made it 65% toward that ecological maximum on that soil's natural capacity to store carbon. With mineralization of nitrogen, this soil health management system has made it 43% of the way there. With resisting erosion, it's made it 77% of the way there. So this is part of how we're thinking about it. We take into account these inherent features and understand how these indicators can tell us about how far along we've made it towards that ecological maximum. And so one of the things that we have done and we are doing, and this is a nationwide stratification plan, but it is relative to what we're looking at in California here. So here we have the counties of interest, Mendocino, Sonoma, Napa, Marin Lake, and they are colored by this soil strata. So instead of having every single map unit on here and saying that every single one would be different, we would never get to a big enough data set to be able to say something meaningful about every specific soil map unit. But what we have is this soil strata that are categorized in three ways. One is kind of that activity. In the legend here, you see plus, minus, BS. That is kind of this activity level, and then texture, and then the drainage class. And so each of these colors on here is something that we want to be able to sample. We want to be able to sample each of these strata in the different areas. And so if we zoom in on just kind of Napa, a little bit north of Napa, we have now, instead of having 200 different map units or soil series, we have about 10 different ones that we want to measure. And if we can measure the reference state and the soil measurements in each of those areas, then we can't, for that specific soil strata, we can compare any production system to that reference and get an idea of how far along the chain we are, so that we can have this relative scoring system that makes sense for the place, the soil type, the microclimates that you are in. And so, like I said, we've been working on this as far as a reference idea. We're rolling it out in Washington and in Texas and in Arkansas and in California, Idaho, Wisconsin, and New York. So we are ground truthing this right now. And we are hoping that the next year, when we are presenting this data, we'll be able to give you information based on the specific strata that the vineyards are in, so that we have this relative type scoring system. And just to kind of give you a heads up, we are looking at having this minimum suite of soil health measurements that really, because of the redundancy of some of these other measures, this really tells us a lot about what's going on in the soil's ability to function. So using soil organic carbon, respiration, and aggregate stability, comparing those to a business as usual and an ecological reference where those soils are in that similar climate and inherent soil properties, is going to be able to give us quite a bit of information here. And I'm sorry that I had to move through all of that so quickly. I am happy to answer questions. I thought I was going to have a little more time, but I'm happy to answer any questions here or later.
All right, I'm going to jump in, Shannon, and say you did a great job. Sorry you got a little bit rushed there, but you actually presented the material really well, and that makes a lot of sense. It's really exciting to see what's happening, and I think it helps us who are involved with the North Coast Soil Hub and beyond to see the context of what we're doing fits in this much bigger picture, and that just makes it that much more exciting. So I thank you for that. I do want to say a quick, before we finish the North Coast Soil Hub talk, and with the question and answers we have with the time remaining, a shout out to Charles Chembray, who is I noticed is on. He helped get this going. He used to work for Napa RCD before Miguel was there, and he helped put the grant together. And a lot of what you just discussed was something he really helped lead the charge on, did a great job. Unfortunately, we lost him and he went to work for the University of Nevada, Reno. And but Miguel has come in and done a great job and with a different perspective. So thank you. And with that, Katie, take it away.
Sure, yeah, I'll try and get as many in as I can. I think this would be good for Miguel. We have a question about the timing of the annual soil health samples. Could you speak to that?
Yes, so we have been making an effort to collect our soil samples during the late winter, early spring. And our motivation has been mostly soil moisture. We want to make sure that we are consistently collecting the soil samples with sufficient moisture, but that also makes the sampling a lot easier. If we were to be going in the middle of the summer when the soils are completely dry, it'll be very difficult to actually extract the samples. So late winter, early spring. So around this time is when we are actually out there collecting the samples.
Great, thanks. And Shannon, could you speak a bit more to what you would like to see for these reference state samples for soils? Is this like a naturalized vegetation system, or what are you looking at?
Yeah, so there is the potential to have a little bit of variation. One of the things that we're looking at kind of as the first push is a minimally managed perennial grassland area. What we have seen is that, the grassland really epitomizes a lot of what we are looking for in soil health, right? It's covered all year long. There's often quite a bit of diversity. There's a lot of roots going deep down into the soil. It has all of these soil health principles built into it. We recognize that not every site used to be a grassland, and so maybe it's not its native ecological principle, but we can normally find something where there is a grassland, and in our soil health assessments, we often see these highest values from these grassland systems. And so we're using that as somewhat of a reference or a target for what we might be able to get into, recognizing that there's also the potential for some of these numbers to go even higher. I have measured a lot of systems, especially when you get into a grazing type system, where you have considerably higher carbon storage potential, higher water infiltration, higher water storage, because of that added organic matter. If you have a properly managed graze system, I've also seen the worst soil health scores in a poorly grazed system, but in well-managed grazed systems, that's where we see our best soil health assessments and our highest amount of ecological potential. So there's kind of this native ecological idea of the capacity to function. And then we know that you can move beyond that as well. And it's, then we want to kind of also not go to the point where we are losing more nutrients. Sometimes if you get a really high nitrogen mineralization potential, you're going to have more nitrous oxide emissions and more nitrate leaching through the groundwater. So we want to understand that this is not always a more is better. There is kind of this ecological optimum where we see these tight cycles and things really working together to benefit, that plant health and soil health of the system. So one of the other things that I think would be great in these targets is if we can get these targets for multiple native ecological sites, and maybe that will be a project that we're moving on in the future. To start with, we're starting with these minimally managed grassland perennials.
Great, thanks. And could you follow up too with what is the depth of soil sampling and why do you use that depth?
Yeah, so for a traditional soil health assessment, we use a 6-inch or 15 centimeter sample. In all of these reference projects, particularly because there is this emphasis also on soil carbon storage, we're going to 30 centimeters or 12 inches. The reason that it's been top 6 inches for a long time is because that's where the majority of the biological activity is in a lot of row crop systems. If you get a good grass system, you can get roots down deeper, you can get plenty of biological activity down deeper, but there is always a gradient. And so we start out looking at that top 6 inches. Hopefully we'll move deeper down into the soil as we move forward.
Great, thanks. And Miguel, how about you for this one? Are our California Ag Labs set up to process soil health samples and interpret them And if not, what are we doing about that as a soil hub?
That's a good question. So we partnered up with Oregon State University because they are a research institution, so their lab follows research protocols. I wasn't here when the conversation started and why we went with them. I've worked with other labs. I mean, I've sent samples to other labs in California. And the problem is that not every lab is equipped to do the suite of assessments that we want to do as we're following changes in soil health. And the second thing is that currently there's no regulations really checking in on these commercial labs to see how accurate the results are. So because this was going to be a very research-driven project, we wanted to make sure that we have results that are accurate and that are going to be reliable. So that was our decision making process. There's other institutions. We have UC Davis nearby that also has a soil health lab that will be able to do a lot of the same suite of sampling that we want to do. But we found that Oregon was one of the few that will do everything in just one single sample. So we just send them one sample. If we were going with local labs, we would have to send different samples to different labs to be able to cover everything that we're doing. That's not necessarily what growers will need to do. We're doing this because we're covering more parameters. But I mean, local labs here will give you a lot of information as a grower, this was more of a research project, so we wanted to cover more.
One thing too I would say about that is that we are working on a proficiency program for soil health tests. A lot of soil labs participate in proficiency programs so that, you know, if you send samples to one lab or another, they're at least relatively similar. It has been a problem with soil health tests because there has not been a standard operating procedure, and there is quite a bit of variability in how samples are handled. And so that is also an active area of work that I am participating in, is that lab standardization of soil health. And as more and more people are interested in soil health, there are more labs that are doing this now. So, you know, when Keith contacted me 5 years ago, there weren't that many labs doing soil health at all. And now I'm working on, some new large projects, and I was able to get bids from 5 different labs that would perform the full suite of measurements that we were looking for. And so, you know, it's exciting to see more labs taking this on, and I will say, none of them were in California. So hopefully we'll get a good California lab on board once we have the standardization and people have a better idea of the reliability of these tests.
Okay, I'm gonna jump in and say we have time for 1 or 2 more questions, and then we're gonna go just about 2 minutes late. The Zoom won't cut off at noon, so we're just gonna squeak a little longer. And Katie, whatever you think is best to ask.
Sure. Yeah, I think people are interested in learning more about how you're actually collecting the data. Do you have a team, or are you collaborating with other entities? I think maybe both of you could speak to that a bit.
I would say both of us probably have teams, right? So as far as ground truthing, we have hired quite a few different project scientists, and we're going out and collecting samples. We're not just relying on others' data sets. We want to make sure that the samples are collected in a uniform time, uniform time of the year, which we try to do as close to, before spring activities start as possible. And so we have a whole team of different people going out and taking samples using intact cores for bulk density and intact available water holding capacity, as well as augers and spades and soil knives for collecting the surface soils.
You have anything to add there, Miguel?
I mean, we do everything ourselves. So each RCD has a team that goes out there and collects the soil samples. And we partnered out with Shannon to help us with the data interpretation. So that has been an approach. We do it in-house, and then we're going to be working with Shannon to figure out what the data means.